So hello everyone and welcome back to the second part of carbon and its compounds, which is the last chapter of our class 10th chemistry. All the notes are available in the description section, and for more content you can visit our website, which is STUDIFYSUCCESS.com. So in the part 1 of this chapter we have already covered the basics and the various fundamental topics of covalent bonding. We'll start this video with nomenclature of carbon compounds, which is a very important topic and it is a slightly tricky topic, but I'll make it super easy for you. So let's start with nomenclature of organic compounds or hydrocarbons. So nomenclature is basically the naming of the compound. Every compound needs a name and it is the naming of the compounds. So IUPAC, which is the International Union of Pure and Applied Chemistry, they have set certain rules and certain steps in which every compound is named all over the world. So we are going to study that, and we are going to name various compounds of organic chemistry. So the general format for nomenclature of any organic compound stays the same, and we just have to follow this format and then we'll be able to name the compounds. So the main important thing is the word root. Word root is okay, so we choose the word root depending upon the number of carbons in the main chain. How many carbons are there? Based on that we select a word root for every compound. To that word root we add certain prefixes and we add certain suffixes. So for prefixes, firstly, if I have a branch or if I have a functional group, for example if I have a halogen whose prefix is used, so firstly I'll give the position of that substituent or that branch. If I have a branch on the carbon chain, I'll tell the reader where that branch is, if it is on the second carbon or on the third carbon. So according to that I'll write the position of the substituent, then the prefix is used. Similarly the primary suffix, okay, so the primary suffix is whether the compound is an alkane, alkene or alkyne. The primary suffix denotes these three. After the primary suffix we again tell the position of a specific substituent. If a functional group is present on a compound, we tell the position of that functional group. After telling the position of the functional group, we add the suffix of the functional group, which tells us that which functional group is it. We do not write the complete name of the functional group, we use certain suffixes. I have already told you the prefixes and suffixes of the functional group in the previous video as well. So if you have not checked it out, please go and check it out. So the first step, this is the general format. The first step is to select the word root. How do we select a word root? We take the longest carbon chain. So how do we take a longest carbon chain? So considering this example, I have drawn this carbon chain, this carbon skeleton I have drawn. So we'll count the number of carbon atoms and we'll consider the longest chain. So if I start counting from here, I have one carbon, this is the second carbon, third, fourth and fifth. If I count in this way, I have 5 carbons. If I take this carbon as well, so 1, 2, 3, 4, 5, in this way also I have 5 carbons. So the longest carbon chain is the 5 carbon chain, and this molecule is the branch at the second carbon. So this is the second carbon. We take this longest carbon chain and we number it 1, 2, 3, 4, 5, and then we consider the number of carbons which are present. So here we have 5 carbons. Now according to this number of carbons we select a word root. For selecting a word root we have these options. So if there is one carbon in the chain, we use the word root meth. If there are 2 carbons we use eth. If there are 3 carbons we use prop. For 4 carbons the word root is but. For 5 carbons the word root is pent, and for 6 carbons the word root is hex. Similarly, for 7 carbons it is hept, for 8 carbons it is oct, and for 9 carbons it is non, for 10 carbons it is dec. So here we have seen that we have 5 carbon atoms in the longest chain, so we will use the word root pent. Now ahead of pent we have the primary suffix which denotes alkane, alkene or alkyne. If I see this carbon chain which I have considered, all of them are single bonds. This means that this is an alkane. So for alkanes we use the suffix ane. So with pent I will add the suffix ane to it and it will form pentane. So this is how we do the word root and the primary suffix. I hope this is clear. Let's move ahead. So next we have the second step which I have already told you. For alkanes we use the suffix ane, for alkenes we use the suffix ene, for alkynes we use the suffix ine. So depending upon the type of bond we use these suffixes. Then the third step is to identify the functional group. What type of functional group is present in the compound? Okay, if the functional group is alcohol, we'll use the suffix -ol. If the functional group is aldehyde, we'll use -al. For ketones, I have told you we use -one. For carboxylic acids, I have told you that we use oic acid. Double bond, triple bond we have already discussed. For chlorine, bromine and other halogens, we do not use suffixes. We use prefixes for that. We do not use suffixes, we use prefixes like chloro and bromo. Here we have an example of, okay, so considering this example, so let's start from the first step. For the first step we will see the carbon chain. We have 2 carbons here. This means the word root is eth, so I have written eth here. Then we will see the type of bond. The type of bond is a single bond, so it means it is an alkane, so we will write ane, ethane. Okay, now we will see the substituents. We have bromine as the substituent. So bromine, we know we use the prefix bromo, so I have used bromo ethane here. I can also write 1 bromo ethane, but if nothing is mentioned, it is considered that the substituent is present on the first carbon only. So if there is any other carbon, then it is necessary to mention the position of the substituent as well. Then let's consider this. Okay, so let's consider this example first. Here I have only 1 carbon. This means the word root will be meth. And here I can see I have an aldehyde. What is an aldehyde? That at one side there is a carbon chain and at the other side there is hydrogen. So instead of the carbon chain I have hydrogen here as well, which is okay. So this is an aldehyde. For aldehyde we use the secondary suffix -al. So we have made it ethane because there is single bond, there is no double bond. So ethane and -al is the secondary suffix which we use according to the functional group aldehyde. The third example is a little complex, but let's do it. So here we can see that we have 6 carbon atoms. We will start counting. We have 6 carbon atoms over here, and always remember, we always start counting from the carbon atom which is nearest to the functional group. You can see here alkene is the functional group, so we will start numbering from here. This is 1, this one will be 2, then 3, 4, 5, and this one will be the 6th carbon. So we always start numbering from the carbon atom which is nearest to the functional group. So we have seen that there are 6 carbons, but now there is a question. There are single bonds as well, there are triple bond as well. So how do we write that? But maximum bonds are single, only one triple bond is present. So we will just write the position of the triple bond, and the rest is assume that okay, the rest are single bonds. So we just write the position of the double or triple bond in such cases. So we have hex, and we write the position as 1, and then we write the suffix of alkynes which is -ine, which denotes that there is a triple bond in the first and second carbon position, and there are 6 carbon atoms lined. So this is how we write a particular name of a carbon compound. Let's see some points to remember which are very important. So firstly, always a hyphen is used between a number and a word. For example, here I have written but to all. Between to and all I have placed a hyphen, and between but and to I have again placed a hyphen. So this is how we write the names. So this is important. Numbering of the carbon chain should be done such that the functional group gets the lowest number. This I have told you, that numbering starts from the side which is nearest to the functional group. Now I have this functional group alcohol on this carbon. If I start counting from here, it will give me 1, 2, 3. It will give the function group third position. But what I have told you, that the functional group always gets the lowest position. So we start from this carbon, and from here the functional group gets the second position, and this numbering is considered and this numbering is not considered. This one is considered from where the functional group is getting the lowest numbering. Then if the name of the functional group is to be given as a suffix, and the suffix of the functional group begins with a vowel. So for example, alcohol mein we have O, OL, which is a vowel. So if there is any E, I or anything, that is removed from the word root. So if we see here we don't have any. So if we say here we have propane, I have a ketone which has 3 carbon atoms. So I'll write propane, then I'll subtract E from it, and then I'll write the suffix on, making it propanone. Okay, so these are the 3 points which are to be remembered while naming any carbon compound. I hope the nomenclature is clear. Please do practice of it a lot of times. So this is a very easy concept, but you will get thorough with it once you practice more and more. So now we have the reactions of carbon compounds. We have studied what are carbon compounds, how are they formed, the covalent bonding, how do we name them. Now we will see that how do these carbon compounds react with various other elements present in the environment. First is combustion. What is combustion? Combustion is burning in air. I have told you, whenever we talk about burning, we always use oxygen. Burning is never done without oxygen. So combustion means burning of carbon compounds in air in the presence of oxygen. Now we have carbon and carbon compounds burn in oxygen to give carbon dioxide along with the release of heat and light. So whenever carbon compound is burned in oxygen, they give us carbon dioxide, heat and light. For unsaturated compounds, we get a yellow flame with black smoke, and such flames are called sooty flames or sooty flames because they give us a black carbon type compound which is settled at the vessel, and such flames are called sooty flames. But the saturated compounds always give us a clean flame. Okay, so this is the difference. For unsaturated compounds, we get a yellow flame with black smoke. With saturated compounds, we get a clean flame. But if we do incomplete or partial combustion of the saturated compounds, what does this mean? That the oxygen supply has been cut and there is limited supply of oxygen for the combustion of these saturated compounds, then even the saturated compounds gives us this sooty flame instead of the clean flame which they were giving earlier. Okay, the gas and kerosene stove which we use at home has inlet of air. So you can see this is a stove. In the center you must have seen that there is a hole and there are certain holes in between. Here also there are certain holes. Why are there holes? To provide the stove, to provide the gas with abundance of oxygen, abundance of clean air, so that complete combustion takes place, not the incomplete combustion. Due to the presence of small amount of nitrogen and sulfur, coal and petroleum produces carbon dioxide with oxides of nitrogen and sulfur. Nitrogen and sulfur are major pollutants. Okay, So here we have the reactions. See, we have methane, which is a carbon compound, and here you can see, okay, let's name this again. So whatever you find, just name it, you will get a practice of it. We have 2 carbons, so we name it, the word root is eth. Single bond between the 2 carbons, so ethane, and then OH, so ethanol is the name of this compound. So ethanol, when reacts with oxygen or when is burnt with oxygen, it gives us carbon dioxide, water, heat and light. So heat and light and carbon dioxide, these are the 3 major products which you need to remember for combustion. So let's move ahead. Next is oxidation. What do you mean by oxidation? We have done it. Oxidation means addition of oxygen. Addition of oxygen. Carbon compounds can be easily oxidized on combustion. When we burn it with oxygen, they can be oxidized. Some compounds are capable of adding oxygen to others. So there are some compounds which are called as oxidizing agents. These are certain agents or certain compounds which oxidizes other compounds. Okay, so they add oxygen to other compounds. KMnO4 and K2Cr2O7, which is potassium dichromate and potassium permanganate, are 2 very strong oxidizing agents. So if I have an alcohol and I add one more oxygen to it, I form the oxidized version of it, and this is done by alkaline KMnO4 or acidified K2Cr2O7. Alcohol can be converted to carboxylic acids by the help of these oxidizing agents. This is all about oxidation. Let's move ahead with the next reaction of carbon compounds, which is the addition reaction. Addition, again the name suggests, addition means addition of something is happening. So the unsaturated carbon compounds, as we have seen here, we have an alkene, which is an unsaturated carbon compound. With the help of a catalyst and hydrogen, this double bond breaks and only one bond remains, and addition of hydrogen is there. You can see here we had one bond, that bond has broken and we have hydrogen atoms being added to the carbon atoms. So addition of dihydrogen with unsaturated hydrocarbon in presence of catalyst like nickel, platinum or palladium are known as hydrogenation or addition reactions. What are catalysts? Catalysts are simply substances which increase the speed of the reaction without harming the reaction. So the reaction is not harmed by it, but the speed is increased. So this reaction is very slow if it takes place normally. To increase the speed of the reaction, to increase the rate of the reaction, we use catalysts. So the vegetable oils which we use, they have high amount of unsaturated fatty acids, and we know that unsaturated fatty acids are not good for our health. Hence they are converted to saturated fatty acids by this addition reaction using a catalyst and hydrogen atom. So this is all about hydrogenation or addition reactions. Now let's move ahead to the last reaction, which is the substitution reaction. Again, as the name suggests, substitution means to substitute one atom with another atom, to replace one atom or one or more hydrogen, which is considered here, of an organic molecule by another atom or a group of atoms is called a substitution reaction. Saturated hydrocarbons are fairly unreactive and hence they are inert because they are unreactive. They are very stable compounds, but in the presence of sunlight, chlorine is added in saturated hydrocarbons at a very fast pace. So we have methane over here. Chlorine is added to it in the presence of sunlight. So if I give some sunlight to chlorine and a saturated hydrocarbon, I can add a chlorine atom in place of hydrogen. So earlier I had 4 hydrogen atoms. Now I have only 3 hydrogen atoms, and 1 hydrogen atom has been replaced by this chlorine atom. So now we have 2 carbon compounds. You only have to consider ethanol and ethanoic acid, which are in your book. For ethanol and ethanoic acid as well, we have properties and uses which have the main importance. Reactions also are very easy, you can do that. So starting with ethanol. Ethanol is liquid at room temperature. It is a colorless, inflammable liquid. What does inflammable mean? That it can burn, it can very easily catch fire by any little spark as well, and it is soluble in water. The main use of ethanol is the only alcohol which is edible. So it does not cause any harm to humans. Like that, the other alcohols are lethal or are poisonous to us. So it is an active ingredient in all alcoholic drinks which are consumed, which should not be consumed ideally, but ethanol is the active ingredient in the alcoholic drinks. It is also used in various medicines. We have cough syrups and many tonics which have ethanol in it. We have two important reactions of ethanol which are not so difficult. So ethanol, when reacts with sodium, which is a metal, it forms sodium ethoxide. This hydrogen is removed from here and sodium comes in place of this hydrogen. It forms sodium ethoxide and then the hydrogen gas is liberated out. Then we have reaction to give unsaturated hydrocarbon. So ethanol, when reacted or when dehydrated, what do you mean by dehydration? Dehydration means a water molecule is removed. So you can see this OH along with one hydrogen from here is removed as water, and what we get is ethene, which is an unsaturated compound. So from ethanol we have got an unsaturated compound by heating it with excess of sulfuric acid, and it is causing the dehydration of ethanol. So this is all you need to remember about ethanol. Let's move ahead with ethanoic acid. So the next carbon compound which we have is ethanoic acid. We have already discussed about ethanol, and now we are going to discuss about ethanoic acid. Ethanoic acid is commonly called acetic acid, and definitely because it has oic acid as the suffix, so we know that it belongs to the carboxylic acid family. The melting point of pure ethanoic acid is 290 Kelvin, which is very less, due to which it often freezes in winter season. When we have winters or we have cold climates, due to this very low melting point, it freezes in cold climates, and hence it is also called as glacial acetic acid. So ethanoic acid, now we have three names of it: ethanoic acid, acetic acid, and glacial acetic acid. It is acidic in nature as all other carboxylic acids are. Then we have three reactions of ethanoic acid. First is the esterification reaction. As the name suggests, esterification means at the end we'll get an ester formed. So esterification is the formation of an ester. What is an ester? Ester is a sweet smelling substance. Often when you smell ester, ester has fruity like fragrance. So ester is a sweet smelling substance, and it is formed by the reaction of ethanoic acid and ethanol when both of them react with each other in the presence of concentrated sulfuric acid. Few drops of concentrated sulfuric acid are acting as a catalyst over here, and they form an ester along with water. What is saponification? If I use the same ester with sodium hydroxide, then I'll get ethanol and sodium ethanoate, which is a soap. So saponification reaction means at the end we are getting a soap as the product. So formation of a soap is called a saponification reaction. It is formed by ethyl ethanoate and sodium hydroxide, which is a base. It gives us sodium ethanoate, which is a soap. Moving on to the next reaction of carboxylic acid, which is reaction with the base. So when ethanoic acid is reacted with the base, which is sodium hydroxide, so it forms, we know that ethanoic acid is an acid. When any acid reacts with the base, it gives us a salt and water. Here the salt is sodium ethanoate, which is a soap. and which is the salt over here. The third reaction is with carbonates and bicarbonates. Again, we have studied this in metals and non-metals, that any acid when react with carbonate and hydrogen carbonate, it gives us salt, carbon dioxide and water. Similarly, ethanoic acid when reacts with any carbonate, here we have sodium carbonate, it gives us sodium ethanoate, which is the salt here, water and carbon dioxide. Again, with bicarbonate or hydrogen carbonate as well, it gives us carbon dioxide, salt and water. So this is all about ethanol and ethanoic acid. Now we'll move on to soaps and detergents, which is our next topic. Soaps and detergents, we know that we often use soaps and detergents to clear off the dirt and dust. This dirt and the grease, all this is oily in nature, and hence we know that oils do not dissolve in water. You must have seen oil droplets floating over water. So all the dirt particles do not dissolve in water easily. This is why we use some other substance to remove it from the clothes, which are soaps and detergents. So what are soaps and what are detergents? What are the chemical forms of it? So soaps are long chain carbon compounds. They have very long chains and they have sodium or potassium at the end along with carboxylic acid. So what are they? They are long chain sodium potassium salts of carboxylic acids. So you can see R here represents the long carbon chain. This is carboxylic acid, carboxylic ion, and then we have sodium ion at the end. Now due to this, if we see the structure, then this is the long carbon chain. It is represented like this. This is a zigzag manner of representing a carbon chain, and at the end we have a sodium molecule. Here we have a carboxylic ion, and here we have a sodium molecule. So this sodium is the ionic part, which is water soluble and it is hydrophilic. What do you mean by hydrophilic? Hydrophilic means water loving, philic means loving. And this long carbon chain is oil soluble and it is hydrophobic. This means that it fears water. So this chain does not want to come in contact with water, whereas the sodium ion wants to come in contact with water. So whenever we add any soap or detergent in water, the sodium atom, the sodium ionic part comes outside and it forms a circular like substance, and all the hydrophobic part moves away from water and moves inside, forming bond with the oil or the grease or the dirt which is in the clothes. So the hydrophobic part forms bond with this oil and the hydrophilic part comes in contact with water which is present over here. Okay, detergent also, it is sodium salts of sulfonic acids or ammonium salts with chlorides or bromide ions. Again we have the same thing over here. The ionic end, which is this sodium end, interacts with the water. The carbon chain interacts with the oil, and this structure which you are seeing here, this structure is called a micelle. Such structures are formed when the ionic part interacts with water and the hydrophobic part interacts with the oil substances or the dirt. So whenever we wash our clothes or we do something like this, all the dirt and dust are interacted by the hydrophobic molecules and the water is attached to this sodium. Then when we agitate it, you have seen it in a washing machine or whenever you wash your hair, wash your hands, whenever we agitate it, we move it with very fast movements, then this micelle is removed from the clothes, it detaches from the clothes and it moves with water. Because these sodium ions are forming bonds with water, these bonds are so strong that these micelles come in the water, they are dispersed in the water, and hence the dirt is removed from the cloth and the dirt comes in the water. So the water becomes dirty but the clothes becomes clean. So the micelle molecule binds to the oil and the dirt from the hydrocarbon tail, and the water is binded by the hydrophilic sodium head. When agitated, the micelles along with the oil and dirt come out in water and clothes become clean. This is how soaps and detergents clean our clothes. they form micelles, and these micelles, when agitated, they are removed from the clothes and they come in the water, leaving our clothes clean. But there is a problem that the soaps particularly do not work in hard water. Now, what is hard water? So we have two types of water. We have soft water and we have hard water. Hard water is the water which has calcium and magnesium ions in it. Hard water has calcium and magnesium ions in it, and thus does not produce lather with the soap, whereas the soft water produces lather with the soap easily. This means that hard water does not work with soap properly, but the soft water works with soap properly. Why? What is the reason for the hardness? The reason is the calcium and magnesium salts which are present in the hard water. Due to this, detergents are used while washing, while cleaning hair, all these things. For hard water. Soaps are not used for hard waters. What is the reaction basically which is going on? What happens that soap and hard water react to form an insoluble precipitate which is called the scum. So the scum settles at the bottom, it is a precipitate, it settles at the bottom, and hence no soap is there which is there to react with the dirt and dust and form the micelles. So we have to add excess of soaps which can react with the dirt and dust. This is why we use detergents, because detergents do not form such scum and insoluble precipitates with calcium and magnesium ions in the hard water. Thus they remain effective in hard water, and hence we use detergents for cleaning clothes, for shampoos, for all these purposes. Detergents are used rather than soaps. So this is why detergents are used rather than soaps in particularly hard water. But we have seen how soaps work, how detergents work. Both work in a similar way by forming micelles. Just the molecular structure is a bit different, but both work in a similar way. Now this brings us to the very end of the chapter, and we are done with the chemistry portion of class 10th. I hope there is no doubts in these things. If you have any doubts, you can comment in the comment section and let us know about those doubts. Thank you so much for being with me in this whole chapter. I hope you liked the video, and I hope you have understood the chapter, because it is a very important chapter and a very new chapter for all of you. So thank you so much for being with me. For more content, you can always visit our website STUDIFYSUCCESS.com, and all these notes are available in the description section. Thank you so much.